Alright, geometry, this is the review of the test. I'm going to keep this stuff out on YouTube for you guys. I'll explain it to you Tuesday. This was the quiz we had on measuring line segments. People did it terrible at it. So we're going to start doing these videos. So there's not going to be any excuse. You won't have to take any notes. Well, I guess you will, but they'll be minimal. So the question is, what was the question? What is the length of segment BD? BD is equal to what? Question mark. So remember we covered the formula, BD. BD is equal to the absolute value of -6 minus a +1. So that's going to be what? Negative times a positive is going to be negative. So it's going to be basically -6 minus 1, right? So that's going to be what? -7 inside the absolute value, right? Well, what do we do when we take this value out? It's equal to 7, +7, because as we discussed before, the absolute value is what? Just the distance. See, it's the difference or distance from 0. That's +7. All right. So regardless of whether it's negative or positive, the distance is still 7. All right. So that's why the absolute value is always positive. A distance is always going to be positive. Okay. All right, that's we only got 10 minutes on here, so let's see what we got here. It's only 2 minutes. Okay, G, H, and I. This is number 2. G, H, and I are collinear, and H is between G and I, just like it says here. It says if GH is equal to 12 and GI is equal to 23, what is the value of HI? So I was looking for this distance right here. Let me go ahead and draw it out here. Alright, so this is G, H, I, is that right? Yeah, okay, G, H, and I. It says that GH is 12, so from here to here is 12, and GI, the total distance, is 23. So it looks to me like we just need to subtract this guy from 23, and it's going to give us this length right here, right? Makes sense to me. What is HI, right? So we've got a total length of 23 minus 12, or minus 12. It's like 1, it's like 11, right? And that is the answer. Alright, I'm going to go ahead and, how much time we have here? Okay, we got, it's only 3 minutes, we got up to 10 minutes. So let's go ahead and do number 3. Alright, number 3. Draw this out. We've got X, Y, and Z. Let's see, we got this guy going here. And it says this guy was 7, this guy is 2t minus 1. It says, look at the diagram below. If x, y, this segment right here, is, so x, y, is equal to 7, and xz is equal to, wait a second, x, xy is equal to 7 and xz is equal to 30, since total length is equal to 30, what is the value of t? All right, so what do we have here? We have the addition. Remember the addition postulate? We've got two different length lines. Let me go ahead and draw this out for you a little bit better here. Two different length lines. We got this little line segment right here, and then this one right here, right? Let me see if I got a different color pen laying around here. Let's see here. Yep, sure do. So we got this line segment. Run out of time, I'm just taking the pins out. And this line segment, two different lengths, right? But we've got the total length. So what's the equation going to be? The equation is going to be 7 plus 2t minus 1 is equal to 30, right? Because this line plus this line is equal to this total length. Now how do we solve for t? Easy enough, right? We're going to combine, let me set this down here. We're going to combine these guys right here, right? We don't have to move them over. We just combine them on this side of the equal sign. We've got a 7, a plus 7, and a minus 1 is going to be what? So we're going to have 2t. Combining these two guys in green, we're going to have plus 6, right? Is equal to 30. Now we subtract 6 from both sides. This goes to 0. We're left with 2t is equal to what? 24. Multiplying by, to get rid of this 2 here, we multiply by 1/2 both sides. Or divide by 2, whichever way you want to look at it. These 2's cancel. They go over here. So we're left with, I don't know if you can see that. I'm assuming you can. Well, let me write this up here in case you couldn't see it. We were left with 2t is equal to 24. And we need to solve for t, so we multiply. Let's just say we divide both sides by 2. So t is equal to 12. Let's see how much time we got left. All right, plenty of time. All right, that was number 3. Let's go ahead and do number 4 here. I suggest you guys rewind this and take notes, or because this stuff's coming back at you. Number 4. All right. It says the midpoint M is the midpoint of Ln. What is Lm? M is the midpoint. You can look at your paperwork too. M is the midpoint of segment Ln. What is Lm? I'll draw this out for you. Okay. This is the midpoint segment issue that we went over, okay? Let's see here. We've got L. This is the midpoint. And N. So we've got 3x, and this line segment is 2x plus 1. I'm sorry, 2x plus 2. All right. So what does that mean? Well, it means that this line segment right here, 3x, is equal to 2x plus 2. These line segments, since they're the midpoint, are equal distance to the outside, right? So how would we set that equation up? It says M is the midpoint. What is Lm? That guy. So these two are equal, 3x plus 2x plus 2, so we're going to set those equal. 3x is equal to 2x plus 2. All right, we need to get the x's on the same side. So the first thing we're going to do is subtract 2x from both sides, minus 2x. Okay, that's going to give us what? Positive x. That's equal to, that's going to go to 0 is equal to what? 2. So x is equal to 2. So we're looking for Lm, so we take what? This 2, plug it back in here. So we've got 3 times 2, 6. That's your answer. What is number 5 is, let's see, let me just draw this in a different color here. It says, what is Ln? What is Ln? Alright, well Ln is equal to 3x plus 2x plus 2, right? That's what Ln is, right? And x is equal to 2, so it's going to be 3 times 2 plus 2 times 2 plus 2. It's going to be 6 plus 4 plus 2. It's going to be 12, right? And what was the other answer? So this guy was 6. Makes sense, right? We figured out that, yeah, this guy was 6. 3 times 2 is 6. Makes sense, right? That should be 12 because these guys right here are exactly equal, or half, right, of the total length. All right, this is the way we're going to do geometry from now on.